So class, this is your homework review from the last class we had on Friday. So this is grade 10 scientific investigation skills. We're continuing the things we learned last week. I gave you homework where I asked you to convert 127 meters cubed into kilometers cubed, centimeter cubed, and millimeters cubed. The key to starting all of these calculations is to make sure that you have the unit you want to cancel opposite. So this is your conversion factor. This is the unit you're trying to cancel. So you're going to put meter in the denominator here so that it can cancel with meters cubed in the numerator. And I'm going to raise it to the power of 3 because volume is a three-dimensional quantity. So it's length, width, and height. So you'll have to raise it to the power of 3 to take into account all three of those dimensions. So when we distribute that power of 3 into the bracket, this is what it turns into. The 1 becomes cubed, the kilometer becomes cubed, 10 to the power of 3 is also cubed because I've rewritten 1,000 as a power of 10, and then meters is cubed as well. So that allows me to cancel meters cubed, and we can rewrite the answer that it's going to produce. 1 will stay 1, so we're going to have 127 over 10 to the power of 9, because 10 to the power of 3 raised to the power of 3 becomes 10 to the power of 9 kilometers cubed. Now, we know from the rules of exponents that you're allowed to bring an exponent from the denominator to the numerator, but when you do that, the exponent changes sign. So what you have now is 127 times 10 to the minus 9 kilometers cubed. And then if you want to put it in scientific notation, you take the decimal from here and put it to there. So it becomes 1.27 times 10 to the power of 11 because you jumped the decimal over twice. There's your answer in, minus 9, so it goes up to minus 7. Because I made this number 100 times smaller, I have to make this number 100 times bigger. Basically, you raise the power. Remember, the rule of thumb I gave you last week was when you move the decimal this way, you move the power up. So in this case, the power became more positive. When you move the decimal that way, your power goes down. So here's your decimal. There's your power. Here's your decimal in this case. And this is what happens to the power. Okay, so that's your first one. Now let's do centimeters cubed. So you're at 127 meters cubed, and you want to have meters in the denominator. And we know that there are 100 centimeters in 1 meter. But because you're doing three-dimensional, you're going to raise it to the power of 3. Now let's rewrite that 100 as a power of 10. We're going to get 127 meters cubed times 10 to the power of 2 raised to the power of 3, because now you're distributing the power of 3 in there. Centimeters cubed. 1 is also raised to the power of 3, but that's not going to change anything. And finally, meters is raised to the power of 3. Now you've distributed your power of 3, and you can simplify it. 127, the meters cubed will cancel now. 10 to the power of 2 raised to the power of 3 gives you 10 times 10 to the power of 6 centimeters cubed. And to put it in scientific notation, move your decimal from here to there, so you'll have 1.27. You've made this number 100 times smaller, so you make this number 100 times bigger by raising its power by 2, and there's your final answer. So 127 cubic meters is equal to 1.27 times 10 to the 8 centimeters cubed. Let's move to this board. And do the remaining question. It's better to pick up the whole class and move it than to erase the board. Of course, I'm only picking you up virtually. So you have 120, it was 127, wasn't it? Yeah, 127 meters cubed. And you want to convert it into millimeters, so we're going to say there's 1,000 millimeters per 1 meter. That's in linear measure. You always start off by linear measure, and then you add in how many dimensions it's in. Well, we're converting a volume, so it's 3 dimensions. We're going to rewrite it now to include an easier way of working it by writing 1,000 as 10 to the power of 3. Raise that to the power of 3, and then you get millimeters cubed, 1 cubed meter cubed. And that causes this to be canceled. And then we simplify it, writing 127, 10 to the power of 3 raised to the power of 3 is 10 to the power of 9 millimeters cubed. The 1 doesn't do anything because it stays 1. And now we turn it into scientific notation by moving the decimal from here to there. So it'll be 1.27 times 10 to the 11 millimeters cubed. And that is what 127 cubic meters equals. Now you can try this problem to test your skills, and I'll give you the answer tomorrow. 1 meter is equal to 10 to the power of 9 nanometers. So how many cubic nanometers are in 127 meters cubed? All right, just use the same technique. You won't even have to use a calculator to solve it. The next thing I'm going to do is review your scientific notation. So this is a sheet I'd like you to try. It should be very easy for you. Here's the instructions. So let me get a sheet for myself too. So it says express each number in scientific notation. And here are the exercises. Hopefully you can read them from that distance. You can do that for homework. It shouldn't take you more than 5 minutes. If it takes you more than 5 minutes, you haven't learned it sufficiently well. It's really a quick exercise and just a quick review of what you should know already. So we'll do that tomorrow. The next thing is discussing powers of 10. We discussed it probably in the last class, but I'd like to just remind you, 10 to the power of 3 is equal to 1,000. 10 to the power of 6 is equal to 1,000,000. 10 to the power of 9 is called a billion. And 10 to the power of 12 is a trillion. All right, so if you take 1,000, multiply it by 1,000, you get 1,000,000. If you take 1,000,000 and multiply it by 1,000, you get 1,000,000,000. And if you take 1,000,000,000 and multiply it by 1,000, you get 1,000,000,000,000. So here's your, it's good to remember these. 1,000, millions, billions, and trillions. And the typical way of writing large numbers is you just put every 3 zeros or every 3 numbers, you put a little space. In Europe, they like to put little commas, but that's not really the metric system. Metric system, they want you to put little spaces between every group of 3 zeros. And just to put it a little, to put it in a ballpark, that's less than what Canada owes in national debt. Right now, we owe $1,200,000,000,000 to the banks. And no, that will not balance itself anytime soon, no. The next thing is some practice in factor labeling. So I'm going to give you a few exercises where we're going to learn how to change units one after another. We do it sequentially, bit by bit, and even if it's a complicated problem, it ends up being easy because you do it one small piece at a time. First you worry about the units, then you worry about the numbers. So it's actually easier than it looks. Here's the first question. I'll start you off easy. what is 0.032 grams converted to milligrams? So if you have 0.032 grams and you want to convert it into milligrams, what are you going to do? Well, you have to know your conversion factor. 1 gram equals 1,000 milligrams. You have to know that. So we're going to say 0.032 grams times, where do you put grams? You put it on the bottom because you want to be able to cross out grams. So if this grams is in the numerator, you've got to put the thing that you're going to cross it out with in the denominator. So we're going to say there's 1,000 milligrams for every 1 gram. Grams will cancel, and we're going to get, we can also replace this by 10 to the power of 3. So we can say 0.032 times 10 to the power of 3 milligrams as our answer. That's not in scientific notation, so we're going to fix it by shifting the decimal over 2 spots so that you get 3.2 times 10 to the power of 1. Because I jumped it over to the right, the power goes down by the same number of jumps. So 2 jumps down means reduce it to the power of 10 to the power of 1. And by the way, 10 to the power of 1 equals 10, so 3.2 times 10 gives you an answer of 32 milligrams. So you can report that as your final answer if you like. Either one is correct, but it's good to be conversant in both. And the next one is convert 0.436 meters cubed to centimeters cubed. What you need to know to work this problem is that 1 meter equals 100 centimeters. If you know that, then you can start by saying 0.436 meters cubed times 100 centimeters per 1 meter. Because it's in 3 dimensions, you see this is in 3 dimensions, it's a volume measurement, so you're going to have to convert it by raising your conversion factor to the power of 3 as well. That can be turned into 0.436 meters cubed times 10 to the power of 2, which is another way of saying 100 centimeters. Oh, and I have to raise that to the power of 3 because I'm distributing my power of 3. Centimeters cubed per 1 cubed, which is still going to be 1 meter cubed. Meters cubed cancel in my big bracket. And then I'm going to get an answer of 0.436, 10 to the 2, raised to the power of 3, gives you 10 to the 6, so times 10 to the power of 6, centimeters cubed. Now and divided by 1, which doesn't change anything, so we don't bother even writing it. And then what we do is we move our decimal to 1 step to the right to get the proper scientific notation. So it's 4.36 times 10 to the power. I made this number 10 times bigger, so I'm going to make this number 10 times smaller by dropping the power by 1. And there you go. There's your answer. The next one is trivial, but it's worth knowing. 302.1 milliliters to centimeters cubed. You need to know that 1 milliliter equals 1 centimeter cubed equals 1 cc. Sometimes you'll see that used. cc. I'm sorry about the glare. I'm going to have to put a sheet of paper on that window. We don't have a blind. It fell off for some reason. So that glare in the middle of the board is because of that. But I'll deal with it in the next couple of days. So 1 milliliter is equal to 1 centimeter cubed equals 1 cc. You'll see that written on the side of syringes very often. But they all mean the same thing. Typically, this is used for liquids. This might be used for solids, but they're interchangeable, really. They basically relate the same quantity, same volume. They all relate volume, and it's the same thing. But the correct SI is centimeters cubed. So the answer to this is trivial. It'll be 302.1 milliliters times 1 centimeter cubed per 1 milliliter. Milliliters cancel, and you get the same number, with a different unit. Okay? So just take that in, and I'm going to erase the board and do some harder ones now. Now, the nice thing about recording lessons, pre-recording lessons, is that you can pause me and try to solve the problem on your own to see if you can preempt me. And that way, you know if you really know it, because you can follow along with me and still not really get it. It's better if you occasionally pause the video and try to answer the question without my help, and then turn me on again and see if you got it right. Number 10 is to convert 0.693 decimeters cubed to centimeters cubed. Okay. You'll have to know to solve this that 1 decimeter is equal to 10 centimeters. Don't worry about the cubed part, we can fix that later. So 0.693 decimeters cubed times 10 centimeters per 1 decimeter. But then we're going to raise it to the power of 3 because it's a volume conversion. See, decimeters cubed means the volume. Let's distribute that power of 3. What we'll get is 0.693 decimeters cubed times, open bracket, 10 to the power of 3 centimeters cubed over 1 to the power of 3 decimeters cubed. Allows you to cancel decimeters cubed. So your answer is going to be 0.693 times 10 to the power of 3 centimeters cubed. The 1 becomes still 1, so it doesn't change the value of anything. And then to convert it to the proper power, we're going to move one number before the decimals and the rest after, so it'll be 6.93 times 10 to the power of, I made that one 10 times bigger, so I'm going to make that one 10 times smaller, so that goes down to 10 to the power of 2 centimeters cubed, and there's your final answer in scientific notation. Let's do one that's a little more difficult, like say this one. 9.06 kilometers per hour being converted to meters per minute. Ooh, a mild challenge. Okay, so to solve this, you have to know that 1 kilometer is equal to 1,000 meters, that 1 hour equals 60 minutes, and yeah, it's not even that challenging. Okay, so we'll do 1 unit at a time. We'll attack the kilometers first, and don't worry about the other one. So we're going to say 9.06 kilometers per every 1 hour, and I want to get rid of kilometers, so I know there's 1,000 meters in a kilometer. Crosses out kilometers. Don't even worry about the numbers right now. We're going to continue getting rid of units that we don't want. We also want to get rid of hours by converting them into minutes. So we know that there's, hours is in the denominator here, so I want to get rid of it by putting hours in the numerator. So I'm going to say 1 hour per 60 minutes. That allows me to cancel hours. Cancel over here, cancel over there. What are the units that didn't get canceled? Meters per minute. Lo and behold, that's the answer we're looking for. Now you worry about the numbers. So 9.06 times 1,000 divided by 60. I can't really do that in my head, so I have my calculator. 9.06 times 1,000 divided 60 gives you 1.51 times 10 to the power of 2 meters per minute. Let's try one that's a little more challenging. Liters, okay, let's try this one. 0.78 liters per 1 minute want it to be converted into centimeters cubed per second. What do we need to know to solve this? We need to know that 1 liter equals 1,000 milliliters, and we also need to know that that 1 milliliter equals 1 centimeter cubed, which we set up there somewhere not too long ago. And we also need to know that 1 minute equals 60 seconds. So there's 3 conversion factors we need to work to solve this problem. So let's work on getting rid of liters first. So I'm going to rewrite over here to start over the problem. Can you see that? Yes. 0.78 liters per minute times, I want to get rid of liters, so I'm going to put liters on the bottom, 1 liter, and there's 1,000 milliliters per liter. That gets rid of liters. Don't worry about the numbers yet. We're going to do only the units for now. Then I want to convert milliliters into centimeters cubed, so I know there's 1 centimeter cubed per 1 milliliter. So milliliters go. And then I'm going to try to get rid of minutes. I know that there's 1 minute for every 60 seconds. And that allows me to cancel minutes. And now I worry about the numbers. So remember, I've told you before, when you're multiplying fractions, any number that appears in the numerator, you press times. Any number that appears in the denominator, you press divide on your calculator. So this is going to look, in your calculator, what you're going to do is 0.78 times 1,000 divided 60. Are you going to bother saying times 1 or divide by 1? No, because it doesn't change the value. So just enter the numbers that make a difference. So 0.78 times 1,000 divided 60 is going to give you the correct answer, and it will be 1.30 times 10 to the power of 1. Now, which units haven't canceled? Centimeters cubed per second. All right, so if you get good at this factor labeling method, you can turn any type of units into any other type of units, as long as they're compatible, obviously, and as long as you know the conversion factor. If you don't know the conversion factor, then you won't be able to do it. Let's do one more example, and then we'll move on to the next thing I want to do, which is finding the surface area of the Earth. You know what would be cool is when you watch these videos, make a comment in the video, just say like, "Hi sir, I watched the video." That way I know that you're getting exposure to the material that's going to help you learn what you need to learn. All right, last one. 81.42 nanometers per second. Whoops. And I want you to convert that to centimeters per minute. All right, so what do you need to do? What do you need to know to solve this? You need to know that, because I don't know what the conversion factor from nanometers to centimeters is, but I do know the conversion factor from nanometers to meters and the conversion factor from meters to centimeters. So I'm going to do that in 2 steps. And then seconds to minutes is obviously very easy. So 1 meter equals 10 to the power of 9 nanometers. You need to know that. 1 meter is also equal to 100 centimeters. You need to know that to solve this. And you need to know that 1 minute equals 60 seconds. Now we can solve it. So 81.42 nanometers times 1 meter per 10 to the power of 9 nanometers. This is not a volume measurement or anything, it's just length measurement, so you don't raise it to any power. Times, okay, that gets rid of nanometers, times 100 centimeters per 1 meter. That's going to get rid of meters. And now we want to get rid of seconds. Well, seconds is in the denominator here, so we're gonna put seconds in the numerator on our conversion factor. We're gonna say 60 seconds per 1 minute. And that allows us to cross out, oops, forgot to write seconds. Allows us to cross out seconds. There we go. So now you're left with centimeters per minute, which is what you were looking for. Now you worry about doing the numbers, and you can use your calculator to do that. So you got, and you can even simplify a little bit before you start. You see that 10 to the power of 9, this is actually 10 to the power of 2, okay? So 10 to the power of 2, you can replace 100 with that. And then you're gonna see that this 10 to the power of 9 and 10 to the power of 2 can actually partially cancel to 10 to the power of 7 here. So then when you do a calculation, it'll be a little faster because you can say 81.42 divided 1 exponent 7. Now it sounds strange when I say 1 exponent 7 in my calculator, but when you press the EXP button on your calculator, I know students make this mistake all the way to grade 12. When you press that magical EXP button on your calculator automatically writes times power times 10 to the power of, and leaves a flashing cursor there. That's where you write your power in. So when I say 1 EXP, the times 10 appears automatically, and then I write it in the exponent. In this case, I write a 7, and what the calculator says is 1 times 10 to the power of 7. If you say 1 and then exponent times 10, what you're doing is you're multiplying your answer by 10. So when you press that EXP button, don't write times 10 again, because the calculator's already doing it automatically for you. You should play with your calculator a bit and find out what I'm talking about. It's not that hard to figure out, but if you don't figure it out, you end up making that same silly mistake over and over again. Come and see me if you don't understand what I'm talking about, and I'll show you with the calculator in hand. All right, so I said 81.42 divided 1 exponent times 10 to the power of 7 times 60. And that's going to give me the answer. And the answer is 4.8852 times 10 to the negative 4. Yeah, and the units would be centimeters per minute. Don't forget to write the units. Okay, that's enough on that. Next thing is to find the surface area of the Earth. I'm going to start you off on this board. The answer is going to be there. Don't look, don't look. Ooh. All right, go like that. Then we'll erase this side so I can ask you a question. So the question is this: what is the surface area of the Earth? The surface area of a sphere is 4 pi times the radius squared. The volume of a sphere is equal to 4 over 3 pi r cubed. You'd be surprised how many times these formulas come in handy, especially the sphere one, because a lot of things in nature happen spherically. Like, for example, sound. When you make a sound, if you could see sound waves, say when I snap my finger, you'd see circles of sound waves going out in every direction in the form of a spherical propagation. And you could calculate how intense the sound level is based on how far you are away from the person, and what the area of that sphere is where the sound is being propagated. I'm oversimplifying a little bit, but basically it comes down to that. They even did research during the Second World War. When they exploded the atomic bomb, they found out that the best altitude to explode the bomb was around 500 meters, because if you explode the bomb at the ground level, it doesn't destroy as much. Whereas if you detonate it from a high altitude, the spherical wave that it generates causes more destruction. Okay, so we're gonna find out the surface area of the Earth. Here's the question, we just for fun, if you could split up all the land on the Earth, first of all, we'll make a little assumption. We'll assume that the Earth is 1/3 land. It's not exactly accurate, I don't know what the exact number is, but 1/3 is pretty close. 1/3 of the Earth is dry land. Let's pretend there's no mountains and desert, but that we just evenly distributed all the land on the Earth to the 7 billion people that existed on the Earth, including little babies and everybody else. Okay? How much land would each person get? Let's find out. I know one thing about the Earth. I know that the Earth is 7,926 miles across. And the only reason I remember that is because I used to like astronomy when I was a little kid, and I memorized all the diameters of the different planets, and I memorized the Earth. The Earth is actually a little bit fatter than it is tall. It's about 13 miles fatter than it is tall because of the fact that it spins once every 24 hours. That creates a centrifugal force that deforms it from a perfectly spherical shape. But yeah, so the Earth is not exactly a sphere, it's more like a spheroid. It's a slightly distorted sphere. But we can find out its surface area using this formula. But before we do that, we have to find out its radius in kilometers, because I want to find out how many square meters of land we have per person. So here's the question. If there are 7 billion people on Earth, 7 billion persons on Earth, and Earth has a diameter of 7,926 miles, then how much land could each human being own if it was evenly distributed? Of course, that's not very practical, especially if you're the guy who inherited the top of Mount Everest or something, or the the middle of the Sahara Desert. It wouldn't be practical, but it's just a thought experiment, just for fun. So to find out, the first thing we got to do is convert the diameter of the Earth into a radius. So we're going to take half the radius, doesn't matter, because if you're from the center to anywhere on the surface, it's equal to a radius on a sphere. So half of that is going to be the radius of the Earth. So we'll start off with, and I have the calculation done here already, so I'm just going to move you over now to the other board. We start off with the 7,926 miles. We know there's 5,280 feet per miles, which allows me to cancel miles. That there's 12 inches per foot, which allows me to cancel feet. That there's 2.54 centimeters per inch, which allows me to cancel inches. That there are 100 centimeters per meter and 1,000 meters per kilometer. So we've now converted the diameter of the Earth in miles to the diameter of the Earth in kilometers, and here it is, 12,755.6605 kilometers. But we want the radius, so half of that is going to be the radius, and that's what it is. You take half of that number, you get this number. So that's the radius of the Earth in kilometers. We're going to pop it into this formula, 4 pi r squared. There's your squared, so we're squaring that quantity. We're also squaring the unit. That's what you get. Multiplying it by 4 pi, and this is what you get is the surface area of the Earth, and then I multiplied it by 1/3 because the Earth is 2/3 water. In fact, you know, the Pacific Ocean is so large that there is a place on the Pacific Ocean that if you were to go straight down and bore through the center of the Earth and keep on digging until you came out on the other side of the Earth, you'd still be in the Pacific Ocean. So it's a big ocean. In places, it actually covers more than half of the distance around the Earth. So anyway, that's how much land mass, that's how much land area is available on the earth. And then I said to myself, okay, how many kilometers squared would be available per person? Given that there's 7 billion persons, you get 2.4 times 10 to the 2 kilometers squared. Let me just double check that. I think I forgot to put the -2. There's a -2 there. So 170,386,242 kilometers squared divided 7 exponent 9. Yeah, to the -2. So that's what would be the area of the parcel of land that you would get. Let's take the square root of that, because remember that a square, if you look at a square, suppose you had a square that was 4 meters squared. What would be the length of one side? Well, it would have to be 2, because 2 by 2 gives you the 4. So we're going to take the square root of that number 4 to get the length of one edge. So to find out the length of this edge, we're going to take the square root of that number, and it'll give us the length of the edge in kilometers. That's what would be the parcel of land that you would get. 0.156 of a kilometer, multiply that by 1,000, you'd get 156 meters of land. So you get a 1.5 football field this way of length, 1.5 football field length that way. That's how much land there is for every man, woman, and child on the planet. Now, of course, if you had a family of 5, you get 5 of those parcels, so it would be a lot larger now. It could be effectively the same width, but then 5 times longer. So everybody would have plenty of land. And anybody who tells you the earth is overpopulated is lying to you. Okay. Let's do another problem together, and then I'll give you one for homework. The mass of the earth is, no, I forgot. It's 5 point something. Give me 1 second, I'm gonna look it up in a book that I have. It's around 5.7 times 10 to the 24 kilograms. Okay? Is the mass of the earth. The diameter, as we've said before, is 7,926 miles. So what is the density of the earth? Okay, first thing we need to do is calculate the volume of the earth. You can do it in centimeters cubed. I know it sounds like a rather unconventional unit to be using for such a large object as the earth, but remember that density equals mass over volume. And what are the units we use for density? Well, typically we use units of grams per centimeter cubed. So it's not that hard to convert the volume of the earth into centimeters cubed if you know the conversion factors that you need to go from miles to centimeters, or miles to kilometers, and then back to centimeters. So what we're just going to write down the conversion factors we're going to need. 1 mile is equal to 5,280 feet. 1 foot is equal to 12 inches. 1 inch equals 2.54 centimeters. And 1 meter equals 100 centimeters. And I think we have enough there to do what we need to do. So let's start by finding the radius of the Earth, and then we'll plug it into our formula, recalling that the volume of any sphere is given by 4 over 3 pi r cubed, where r is the radius, in whatever unit you choose to use. We're going to use centimeters. So let's find the volume of the Earth, 7,926 miles, times, well, we're going to convert the diameter into, we're going to do all of this in linear, and then at the end we've converted the diameter of the Earth into centimeters. We're going to take half of that, because we want the radius, and then we'll cube it. And that's probably the easiest way to do it. So let's start with 7,926 miles times 5,280 feet per 1 mile. That cancels miles. Times 12 inches per 1 foot. Cancels feet. Times 2.54 centimeters per 1 inch. Cancels inches. We've already got the diameter into centimeters. Then we'll take that and divide it by 2, because we want the radius. Then we'll take all of that and raise it to the power of 3, and it's going to give us the cubic radius, which is what we need to plug into this formula over here. So let's do that right now. 7,926 times 5,280 times 12 times 2.54 gives you 1,275,566,050. Divide that by 2. That's the radius of the Earth in centimeters, and then we'll raise it to the power of 3. Don't have my glasses, do I? Yes, I do. Raise it to the power of 3, and we get the following number. 2.594 292 times 10 to the power of 26 centimeters cubed. Now we're going to multiply all of that by 4 over 3. So the volume of a sphere, the Earth being that sphere, 4 over 3 pi times 2.59, etc., times 10 to the 26 centimeters cubed, gives you the volume of the Earth in centimeters cubed, times 4 pi divided by 3. And here is the volume of the Earth in centimeters cubed, 1.08669453 times 10 to the 27 centimeters cubed. Remember that density equals mass over volume. About the mass, we're told, and actually this is an inaccurate number. I didn't actually find the number, I just made it up, but it's close. So 5.7 times 10 to the 24 kilograms times 1,000 grams per kilogram is going to give you the mass of the Earth in grams, divided by the volume of the Earth, 1.0866, etc., times 10 to the 27 centimeters cubed. You'll notice that when you multiply this by the power by 1,000, it's like 10 to the power of 3. 10 to the power of 3 times 10 to the power of 24 gives you 10 to the 27. So this 10 to the 27 and this 10 to the 27 cancels, and what you get is the density of the Earth. And what we get with these numbers is 5.245. The actual density of the Earth is closer to 5.5. So the number I estimated was a little bit off, but you get the picture. Grams per centimeter cubed. So the Earth is actually denser than water. The density of water is 1. So if you could put the Earth into a giant bathtub, it would sink like a rock because it's even denser than most rocks. Iron has a density around 7.8. Aluminum has a density of 2.7. So the Earth is denser than aluminum, but it's less dense than iron. So a ball of iron the same size as the Earth would be a bit more massive, and a ball of aluminum the same size as the Earth would be about half the mass of the Earth. Now here's what you're going to do for homework. I want you to calculate you can model yourself on this. It uses the same formula, density equals mass over volume. I'll give you a hint. Question. What is the mass of a ball of iron 2 meters in diameter, given that